The prevailing narrative says enterprise AI adoption is stalling because models hallucinate. That's a misdiagnosis. The actual roadblock is controllability. When an autonomous agent makes a multi-hop decision, it executes a chain of logic hidden inside a black box. If the final output is wrong, the chain of fault isolation snaps. No human operator can look at the result and cleanly explain why the machine chose that specific path. In 2024, Air Canada tested this gap in open court. When their customer service chatbot hallucinated a refund policy, the airline argued the bot was a separate legal entity responsible for its own actions. This legal defense is a modern application of a sociological concept identified by René Girard, the scapegoat mechanism. Girard observed that groups in crisis discharge tension by converging all blame onto a single, defenseless victim. An AI agent is the perfect victim for this mechanism. It has no legal standing and cannot defend itself in court. Blaming the machine offers an immediate political release. The vendor blames the model, the deployer blames the configuration, and the executive blames the agent. Everyone is relieved of responsibility at once. But this unanimous blame transfer only provides temporary political relief. By pointing at the machine, the true source of the error remains unfixed. The fault is transferred, not repaired, leaving the enterprise exposed to a repeating cycle of unmanaged liabilities. In economics, this scapegoat mechanism goes by a different name, an unpriced externality. An externality occurs when a cost is severed from its cause. You can only charge a producer for a harm you can accurately attribute to them. Both the sociological scapegoat and the economic externality share the exact same structure. They rely on a detached record, a severed link between the action and the responsible identity, creating a misattribution that everyone in the chain agrees to believe. This exact detachment is why institutions like Lloyds of London and other major carriers are writing absolute AI exclusions into their policies. Underwriters operate on a strict mathematical threshold. They will not write a policy for a peril where the blame is designed to be transferred away from a legally identifiable party. If the liability is severed from the source, the risk cannot be quantified. To reopen the insurance market, that detached record must be grounded. The autonomous action of the AI must be permanently bound to a verifiable human identity at a specific coordinate. If you cannot attribute the failure, you cannot price the risk. If you cannot insure against that liability, the enterprise literally cannot afford to deploy autonomous agents at scale. The software industry currently attempts to manage this risk by building secondary monitors. They deploy a second AI, often called an LLM as a judge, to watch the primary model and catch its mistakes. This approach collides directly with a computer science axiom from 1953, known as Rice's theorem. The theorem states that no algorithm can decide a non-trivial semantic property of another program. Applied to AI safety, Rice's theorem reveals a structural flaw. The primary model and software monitor share the exact same failure domain. Operating in the same computational layer, any semantic drift corrupting the primary agent will seamlessly corrupt the telemetry designed to catch it. Using software telemetry to verify software intent is mathematically equivalent to the system grading its own homework. It generates an illusion of safety that provides zero legal or actuarial cover when an error occurs. To secure undeniable proof that an agent's semantic meaning has drifted, the measurement must happen outside the failure domain.
We have to bypass the software layer entirely and drop directly into the physical architecture of the machine. We move below the instruction set, past the operating system, and anchor the measurement directly on the physical silicon substrate. Instead of attempting to parse the abstract thoughts of a neural network, we translate semantic intent into a strict physical coordinate. This 12 by 12 grid is the fractal identity map. Specific agent roles are assigned to physical memory locations, defining authorized semantic bounds. When acting, an AC0 boundary check compares the decision against this zone. Taking 0.54 nanoseconds, this physical cache hit is immune to software hallucinations. The resulting cryptographic signature, an ED 25519 receipt, contains irrefutable physical proof of the exact action the agent took, permanently mapped to the public key of the human operator who authorized it. Semantic drift is no longer an invisible shift hidden inside a black box. It is a measurable physical hardware event, and by binding that physical event to a human identity, the scapegoat defense is permanently dismantled. This brings us to a crucial conceptual unification. A verification failure, measured in bits at the processor cache, is the exact same property as an unpriced liability measured in dollars. This formula translates the physical hardware measurement into financial reality. The actuarial engine converts the cache-level drift map directly into an insurance premium. The calculation relies on a standard deviation floor and a measured drift ceiling. These physical metrics dictate the final basis points of the premium, sorting the risk score into 3 distinct bands: insurable, loaded, or uninsurable. Global risk allocators operating out of institutions like Munich Re require exactly this kind of verifiable ledger. It allows them to confidently underwrite exposure across hundreds of deploying organizations simultaneously. The cash flow of this system is entirely top-down. The deploying organization pays this premium because the underwriter has accepted the hardware receipt as valid, irrefutable proof that the AI's risk is bounded. The hardware receipt serves as the absolute exchange rate between physics and finance. It provides the actuary with the mathematical floor required to write a policy that was previously impossible to price. This architecture is rapidly shifting from a theoretical ideal into a mandatory business requirement, driven by an impending regulatory deadline. Article 14 of the EU AI Act establishes a strict legal forcing function. It explicitly mandates auditable proof of human oversight for autonomous systems. Under this legal framework, when a critical system fails, pointing to a secondary software monitor will not satisfy regulators. An AI grading another AI cannot provide the legally required proof of human control. Consider the Air Canada defense against an enterprise utilizing the fractal identity map. Instead of arguing a chatbot is a separate legal entity, the protected organization can instantly produce a cryptographically signed receipt, proving exact human oversight at the moment of failure. This hardware-grounded receipt legally binds the autonomous action directly to the deploying organization. There is no detached record, and there is no machine left to blame. By engineering the actuarial coordinate, autonomous behavior becomes verifiable, accountable, and thoroughly insurable. The era of the AI scapegoat is over, and the true scale of enterprise AI deployment is finally unblocked.